Though you might have already studied about definitions of real power and reactive power, you hardly see in any textbook that explains the subtle difference between them, due to the way they are defined. To illustrate the concept, let us consider a simple RLC circuit as shown. Applied voltage V equals Vm cos omega t. Resulting current I equals Im cos omega t minus theta, where theta is power factor angle. Applying KCL, Kirchhoff's current law, V equals I into R plus L di by dt plus 1 by C integral I dt. The first term IR is the voltage drop VR across resistor. The second term, L di by dt, is the voltage drop VL across inductor. The third term, 1 by C integral I dt, is the voltage drop VC across capacitor. Instantaneous power P equals V into I equals I square R plus Li di by dt plus I by C integral I dt. Term I square R represents active power P. Terms Li di by dt plus I by C integral I dt represent reactive power Q. Active power is energy dissipated as heat in resistance R. Reactive power is energy stored in magnetic field L and electric field C. Instantaneous power equals instantaneous voltage V into instantaneous current I equals Vm cos omega t into Im cos omega t minus theta. From trigonometry, cos A cos B equals half of cos A plus B plus cos A minus B. Applying the above relationship, with A equals omega t, and B equals omega t, theta, instantaneous power equals half of Vm, Im, into cos 2 omega t, minus theta, plus cos theta. From trigonometry, cos A minus B equals cos A, cos B plus sin A, sin B. Expanding cos 2 omega t minus theta. Instantaneous power equals 1 by 2 times Vm, Im, into cos 2 omega t, cos theta plus sin 2 omega t, sin theta plus cos theta. Taking out cos theta, instantaneous power equals half of Vm, Im, into cos theta, into 1 plus cos 2 omega t, plus sin 2 omega t, sin theta. The first part, 1 by 2 times Vm, Im, into cos theta, into 1 plus cos 2 omega t, is called real power or active power P. The second part, 1 by 2 times Vm, Im, into sin 2 omega t, sin theta, is called reactive power Q. Let us illustrate real and reactive power concept with a numerical example. The equation for instantaneous power is as shown. The first part is real power, and second part is reactive power. Deliberately we have chosen Vmax as 2 kV and Imax as 1 Ka, so that 1 by 2 times Vmax into Imax is 1, a nice round number. This makes further analysis easy to follow. Power factor, cos theta equals 0.8. Therefore sin theta equals 0.6. Note the power varies at the rate of 2 omega t. This is twice the rate of voltage and current, which varies at omega t. Time period of each power cycle, from max to max, is 10 milliseconds, and not 20 milliseconds. When we say grid frequency is 50 Hz, it refers to voltage and current. Power varies at 100 Hz. The graph for active power variation is shown in red. P varies around average value of 0.8. P is always positive. It oscillates between 0 to 1.6, around average value of 0.8. The amplitude is plus minus 0.8. The graph for reactive power variation is shown in blue. Its average value is 0. It oscillates around 0, with amplitude of plus minus 0.6. At the bottom, workout for P and Q, using textbook equation is given. RMS is max by root 2. VRMS equals 2 by root 2, kV. IRMS equals 1 by root 2, Ka. Cos theta equals 0.8. Sin theta equals 0.6. Real power P equals VI cos theta, where V and I are RMS values. P equals 0.8 megawatt. Reactive power Q equals VI sin theta, where again V and I are RMS values. Q equals 0.6 MVAR. What have we learned new from previous slide? Instantaneous power equals Vm, Im, cos omega t, into cos omega t minus theta. That is equals 1 divided by 2, into Vm, Im, cos theta, into 1 plus cos 2 omega t, plus 1 by 2, into Vm, Im, sin theta, into sin 2 omega t. The first part is instantaneous active power equals 1 by 2, into Vm, Im, cos theta, into 1 plus cos 2 omega t. Average active power equals Vi cos theta, where V and I are RMS values. It is simply called active power P. In the previous example it was 0.8. Maximum amplitude of active power is also Vi cos theta. It was 0.8, around average value of 0.8, in the worked out example. It does not give any extra information, and hence ignored. The second part is instantaneous reactive power equals 1 by 2, into Vm, Im, sin theta, sin 2 omega t. Average value is 0, as it oscillates around x-axis. Since it is 0, irrespective of any power factor angle theta, no additional insight is obtained and hence this is ignored. Maximum amplitude of reactive power is Vi sin theta. It is 0.6 around average value of 0, in the worked out example. It is simply called reactive power Q. What is the lesson learnt? In case of active power, VI, cos theta represents average value of sinusoidal real power waveform. In case of reactive power, VI, sin theta represents maximum amplitude of sinusoidal reactive power waveform. The above is rarely brought out in academic textbooks, taught in engineering schools.